All right, so for this problem, we got the bullet's going to be M1, the block's going to be M2. What we're looking for in the problem is V1 initial. They're asking us to find the speed of the bullet at impact, meaning right before. By the way, what's V2 initial? 0. The block is just sitting there. So the bullet's M1, the block is M2. We're looking for V1 initial, the initial velocity of the bullet. The initial velocity of the block is 0. The information we're given is that the bullet gets stuck in the block. So here, I'm going to draw the bullet in the block here. The bullet goes in, boom, into the block. As a result of the collision, this spring that has a spring constant of 150 newtons per meter gets compressed 80 centimeters, which is 0.8 meters. And then for a split second, everything stops, right? When the spring is all the way compressed, everything stops for a split second, and then what happens? It would shoot back out again, right? But the thing that we're going to use is that at maximum compression, the velocity is 0, right? Everything goes smush, smush, smush. Everything stops before shooting back out, okay? All right, so we're going to do two things here. We're going to analyze the collision. Now, what is always true, elastic or inelastic, it doesn't matter what type of collision. What's always true about collisions? Momentum's conserved. Then, if the problem says that it's elastic, then something else is conserved as well, which is kinetic energy. Okay. Oh, and then by the way, notice here that it says that the block is on a frictionless horizontal surface right here. This surface down here has no friction, which has to be true for momentum to be used in the collision. So anyway, here's our equation for conservation of momentum. So analyzing the collision, we're going to go M1 V1 initial plus M2 V2 initial. So that's our total starting momentum. Now, in this collision, do the objects stick together or not stick together? They stick together. So they share the same final velocity. So we go M1 plus M2 V final. Now, what goes to 0 in this equation? V2 initial, that goes away. That's 0. There is no initial velocity for M2. Okay, so now we're looking for the initial velocity of the bullet, which is V1 initial. So doing the algebra, we're going to get V1 initial equals M1 plus M2 V final divided by M1. What do we need to figure out in order to solve for the initial velocity of the bullet? We need V final immediately after the collision. Can we solve for V final immediately after? Yeah. So look, so now what we're going to do is we're going to analyze the post-collision. So what can we apply immediately after the collision? We can use conservation of energy. Mechanical energy initial equals mechanical energy final. And I know some people are like, Spaldo, you just said that you can't use energy. When can you not use energy? During the collision. But the split second the collision is done, you can use energy. You can use conservation of energy. Does that make sense? So what type of energy do we have the split second the collision is over? The bullet goes into the block. Bam! The collision's done, but then what happens? The bullet block combo smushes the spring. What's our starting mechanical energy? Remember, there's 3 types of kinetic. There's 3 types of mechanical energy. Kinetic, potential of gravity, and potential of spring. What type of energy do we have right after the collision? Kinetic. What type of energy do we have here when the spring is fully smushed? Potential of spring. Okay, so kinetic this is going to be 1/2 mv squared equals 1/2 kx squared. The 1/2s drop out, so v is going to be equal to square root kx squared over m, which is going to be, so you pull the x out, x k over m, right? So let me go up here now. So we have velocity equals x square root k over m. Okay, so that's going to be, so x is 0.8, k is 150. Now you got to be careful here, guys. What's this m? It's the total mass, because the bullet and the block became one. So you got to add the masses together, and you want it in kilograms. So that's going to be 0.112. Does that make sense? You got to use the total mass. So this velocity, when you plug into your calculator, comes out as 29.277 meter per second. Now what is this velocity? It's v final after the collision. So now you come down here, you go 0.112 times 29.277 meter per second, that's a 2, divided by m1, which is 0.012, and you get the answer. So the answer to this comes out as 273 meter per second. That's the initial velocity of the bullet before the collision. So you solved this by analyzing the collision and then analyzing post-collision.